Hello everyone, a very good evening to all. Welcome you back to the LetsUpgrade channel. Hope you are spending a good time with Subrat sir in learning data structures and algorithms. Hi, I'm Harshaj. I am working as a head of operation in LetsUpgrade. I'm here to give you some reference and some links about LMS and to guide you of how you can join your class on Monday. So before moving to that, tell me guys, how are you all? Just write me down in the chat. How are you all? How are you doing? People are very concerned about the assignment that they completed and all. So yes, guys, do complete your assignments. Your certificate, your everything is based on that. Shoaib, are we live? I'm not able to see anything in chat. Just confirm it once, no, Shoaib?
Yes, we are like,
Okay. Yes. Now my chat is refreshing. Okay. Yes, good. So yes, guys. So there is a. I'll not take much time. There's a quick announcement that yes, from Monday we are shifting our class to our learn management system. So do make yourself registered. All the links will be there in the description below. So do the registration. The very first step. Do the registration. Then once the registration is done, in your profile, in the right side, your profile, you can see my programs. So you need to go to my program so that your program will be visible over there. Then go to the particular day 4. So the same time will be live over there. Everything will be there. The chat will be there. So we'll be interacting more over our learn management system. So yes, it is compulsory to make registrations again because all your assignments submitted, all your work submitted to us will be taken considered after the registration is done. So there is again an eligible criteria for the exams and for the certificate also. So you need to submit all your assignments. 75% of 80% of the assignment is submitted, then you will be eligible for the exams. And accordingly, if you pass or fail, then you will be getting the certificates. So if and only if the registration is done on the website, then only your assignment will be counted as a valid. Otherwise, it won't be counted. So it will be out of the list. So do make sure that you are registering on the website. Again, the links is there in the description. If I'll ask all the moderators to put the links in the chat bots also, so that it is a smooth operation for them. And yes, sir. So that is what I wanted to announce. So Subrat sir, rest class is over to you. I'll take a leave
Thank
from the
you.
class. So guys, have fun with Subrat sir. Learn as much as you can. Ask all your doubts. He's here to solve your doubts. So okay, I'll take your leave. Bye bye. Stay safe.
Yeah, thank you. Thank you, Harshraz. So, guys, very good evening to everyone. I hope everyone is all set for the session and are very excited for the session. So, I'll just start with a quick review of what we have discussed in the last session. That was yesterday. So, we started with linked list, right? I had just given some intro about linked list. I was talking about something called dynamic memory allocation, and I said that I would be discussing in like a detail about the dynamic allocation. Yeah, of course. Now we cannot get into like too much of detail because of the time constraint, obviously. But yes, as I've already said, those things, whatever detail I am missing out here, that would be like surely done in the advanced course. That is for sure. So let's start with that same note, guys. The dynamic number allocation. So with that, we would like move forward to our link list. Okay. So let's see this. Voice is not clear. Am I audible properly? Can anyone help out me here? Okay.
so there is a bit
Hello.
bang in your voice. Could you just remove the earplugs?
Okay. Just a moment. Okay, is it fine now? Is it fine now?
Yes, sir, better now.
Okay, fine. Fine then, fine. So guys, so I hope now it's okay.
No, so there's still a bit of bang. Could you remove the earplugs? Maybe it's because of that.
Mhm.
Like, could you switch
Okay.
the mic of earplugs to your device?
Yeah, one second. Yeah, it's the same device. Okay. Is it fine now? Hello? Hello?
Yes, sir.
Am I audible properly now?
Yes, sir, it's perfect now.
Yes? Clear, right? Okay, guys, I am seeing this comment section, so now it's fine. So, yeah, guys, so once again, very good evening, everyone. So, let's start with the session. So, we had done basically introduction to LetsUpgrade today, and I was mentioning dynamic memory allocation, and I said so. Yeah, I hope now it's good to go, guys.
Yes, sir.
Is it fine now? Okay. Am I audible now, guys? Is it fine? Okay. Stuck. It's stuck. Video stuck. Okay. There might be some issue right here, I think. Okay. Fine. So now it's good, I guess. Okay, guys. So see here. I hope it's now pretty good to start. Uh, so yeah, we were talking about this DMA, dynamic memory allocation. So what is dynamic memory allocation? Basically, the memory which we allocate during runtime or during execution. So one is static memory allocation and one is dynamic memory allocation. So the one which is allocated, the memory which would be allocated during compile time is known as static memory allocation. That thing is known as static memory allocation. And if the memory is allocated at runtime, okay, memory allocated during compile time, static memory allocation. Memory allocated during runtime is runtime memory allocation, or you can say dynamic memory allocation. So there are certain functions through which we can allocate memory dynamically, and one of the function is malloc. Okay, you can say malloc, or you can also say malloc, memory alloc. Okay, so this function I would be using a lot basically, and normally we go for this function. Actually, there are reasons why we prefer this function over other function. There are some other function also, calloc, contiguous alloc, or normally we can say calloc, and there is realloc and all. Okay, a realloc is basically to reallocate the already allocated memory. So malloc, and between malloc and calloc, we go for malloc. So let's see the syntax of this malloc first of all. So here we have to typecast it. Okay, see this, what happens. So here, let's say I have a pointer in star p, and I want to store, or you can say I want to make this p point to an integer. So basically I want a memory for storing an integer variable. So obviously I need 4 bytes of memory, right? So let's create it. So how would we create? We will write p equal to int star. Why int star? Because I need to store an integer. I need a pointer pointing to an integer. Okay, right? So int star, that would be type basically malloc returns void star. Okay, the default the syntax, default return type of malloc is actually void star, and we have to typecast it into int star basically, because we want this p to point to an integer. Okay, so malloc, and we need size of only okay, my bad, this would be size of one integer, which is maybe 4 byte. So when this line would be executed, this one memory would be allocated 4 bytes basically. You can say that would have an address. Let's say we'll go for 101, and that address would be returned to this p. So p is the pointer which will hold address of this memory location. So we say p is pointing to this memory location, and this memory location will contain an integer, as we have created allocated memory for an integer here. Okay, so how can we store a value? Obviously through this star p equal to, let's say, 20. So 20 would be stored here. Okay, so this memory, the memory allocated dynamically, is allocated from heap memory area, and this pointer p variable, this is basically a local variable, so this would be allocated or created in stack memory area. So there are different memory areas, right? Heap, stack, and there are certain memory area for where local variables are stored, that is stack basically, and somewhere the instructions are stored. So there are different memory areas. Let's not get into those details right now in this session. Let's keep that for the advanced section, because I don't want to waste this limited time on that theoretical discussion, guys. So let's move on to the important part. So this is like basically how we allocate memory dynamically at runtime. Okay, so when we write this malloc, malloc, and we have mentioned how many bytes of memory you want. So we have mentioned here size of int, which is nothing but 4 bytes. So 4 bytes of memory would be allocated, and address of that memory would be returned. So malloc would allocate the memory and return the address of it. So this p being a pointer will hold address. We say p is a pointer pointing to that memory location. Okay, so this memory for of p, this one, this is allocated. So this p memory, okay, this is allocated during compile time when we have written this statement, but this memory is allocated during runtime, during execution. That is why it is known as dynamically allocated memory. So this is about your dynamic memory allocation, guys. In linked list we would be using dynamic memory allocation. Okay, so let's go for it then. I think I had mentioned you the structured definition in the last class. Okay, I'm getting some question. Malloc versus calloc. What is the difference between malloc and calloc? Okay, I'll just give one point here. Malloc or malloc is actually faster compared to calloc. Yeah, someone has also Amit. Amit has also answered this here. Malloc is faster. Yes, malloc is actually faster compared to calloc. Okay, what calloc will do is calloc will allocate memory and would assign or will initialize it with 0 by default. But malloc doesn't do that. Malloc will allocate the memory and it would contain some garbage value initially. If you assign some value, then it would store. So basically, normally we don't want any initial value to our allocated memory. So we can go for malloc as it is faster compared to calloc. Okay, so let's go to the next section. Let's go to the actual linked list actually, guys. So I hope this point is very clear to all of you. So let's go to this linked list. And yes, I have I had told you in the last session about the structure definition, the self-referential structure. So I'll not scribble much here right now. Let's go to this coding platform. Okay, so let's go to code blocks. I'm using here code blocks, guys. So let's go there, and I will show you, like, I have prepared something. I've written something already, this code snippet. So let's try out there. Okay, some part I would also rewrite it for you. So let's go there and see it. Just give me a moment. I'll share that coding platform, and we would be good to go. Yeah. So I hope you were seeing this program, a bit of a program I have written. So what I do is, let me like remove some part, because I want to write it in front of you so that you would understand it better. So let me remove this, even this. Yeah, fine. Let this be there. Let this be there. I would okay. So let me just yeah, do of yeah, let me increase a bit of the font size. It would be nice. Okay, so see, guys. So here, okay, there is a typing mistake. Include std and this is the self-referential structure, right? So this is type def. So I want to basically create an alias. Okay, create an alias for this structure, and the alias which I would like to give is node. So instead of writing struct node everywhere, I would just write node, and that would mean this struct node. Okay, I guess I have told already about this type def in the last session. So I hope we don't have to get into that right now anymore. Then yeah, so this is a create function. So this is a prototype for create function. Why I have taken this create function is, guys, see, uh, any, like, let's say we are about to do this add node function, or this insert node function. We will be adding some new nodes, right, every time. So every time you want to add a new node, you have to create the node first of all. I guess I have discussed that already in the last session. First of all, we have to create a node, right? One would be this data part. It would have a data part, then it would have a next part, which is basically a pointer. Okay, so it is basically a pointer to this struct node type. So it would contain address of the next node basically. So two parts would be there. Whenever we allocate memory for one node, these two things we have. Okay, type def is used to have alias, guys, a different name. If I don't use type def here, so you see here, right? I'm writing node star node star. Instead of node star, I have to write struct node star. Everywhere I have to write struct node, struct node, struct node, struct node. Okay, I don't want to write that again and again. So I'm just creating another name for this struct node. So I'm given the name as node, so that it would be relevant. Okay, so say this. Let's go for this, guys. Okay, so node star create, as I said, this create thing, it would have only one task. It would create a new node, and it would return the memory of that new node. Okay, so if you see here, I have taken an argument. Basically, what is this? It would take the data of the new node. Okay, so let's define this create node. First of all, you can see the syntax of struct node here. I guess that's very simple, we have already discussed. And I have, like, given the prototype of two functions here. One is create, and one is this insert end function. So insert end means insert a new node at the end of the linked list. Okay, so let's move on to this create function. Let's try to define this uh, this one, move create function. So node star, I hope it's visible to everyone clearly. Yeah, I see, yes, it's visible. So node star, okay, create, oh my bad, create again. So we'll take this x. What is this x, guys? This x is nothing but data for the node which we are going to create. So this create function will create a node, a new node basically, with this data x, and it would return the address of that node. That is why return type of this function is node star, because it would return an address of a node. Okay, fine. And what is node? Node is nothing but that structure name. Got it? So this is not a pointer function, guys. This is a function which would return an address of node. So return type is node star. Let's see this. So node star create index. So yeah, node star. I'm taking new as a new pointer, and yes, we have to dynamically allocate memory here, right? And we would be using this malloc or malloc. Of course, we have to typecast it into node star. So whatever memory, like if you are creating memory for one integer, you have to typecast it into int star. If you are creating memory for one character, you have to typecast it into character pointer, cat star. Similarly, here we want to create a node, basic a structure node. So I have to typecast it into this node star. If you don't use type def, then you have to write here struct node star. Got it? So m alloc and size of one node. So size of operator would just find out the size of one node. So it's good to write size of node, and it would allocate memory for one node. So as soon as you do this, okay, as soon as you do this, what would happen, guys? Memory would be allocated. So let's get back to this um, whiteboard once again, and let me give you a preview of what we are doing now. Okay, sure. See, so let me clear this out. Okay, great. So this create function, guys, so what I have written is I have mentioned there like node star new equal to node star malloc size of one node, because I want to allocate memory for one node, right? So as soon as this statement is executed, what would happen? So in heap memory area, a memory for one node would be created, and one node contains a data part and a pointer next, right? That we already know. We have this in the structure definition, right? Yeah, so it would have some address. Let's go for the same 101. I normally take this address everywhere if I am dealing with address. So this is my, you can say, favorite number I'm going with. So 101 is the address here, and that would be stored in a pointer called new. So 101 is stored in new. So new is a pointer to this node, you can say. Okay, this is what we have done. And this create function, if you remember, it has taken one argument x. What is that x? X is the data, okay, value for this data part. So now what you can do is, see, this new is a pointer to this structure, okay, this struct node. So how to use this member of the structure? So data is a member of structure, and also this next is a member of the structure. So we cannot just directly use a member of structure. We cannot say data equal to x. We cannot say next equal to let's say 201 or null. We cannot do that, right? So how to access structure member if we have a pointer to that structure? So it's very easy. We have to write new arrow operator of data equal to x. So we are storing the value of x in this data part, and one more step we have to make the, like, new of next, we have to make it null. Why null? Because right now it doesn't know about the next node, so it has to be null right now. Okay, and finally this function create should return address of this new node, the newly created node. What is the address? 101. Where it is stored? In new. So I would write return new. Understood, guys? So this would basically this create function will create a new node. It will store the data of that node. It will store null in the next part, and then finally it will return address of that newly created node. Got it? So I hope this is fine. Let's get back to our coding platform, and let's see there. Let's complete this logic there. Okay, just a moment. I'll just reshare that coding platform with you. Give me a moment. Okay. Yeah, guys. So, okay. Let me before going into that coding once again. Let me tell you. So, when like once we complete with this create. So, create function. What is the task of this create function, guys? So, create function is there just to create a new node and return the address of that node. That's all, right? Okay. And then what we need to do? Then we would be going to this insert thing. Okay, we will talk about insert operation. So I would quickly share this coding. Okay, um, facing one issue here. Just a moment, guys. I'm unable to share the coding platform to you. Just a moment. Give me a moment. Okay. I hope it works now. Yeah, fine. Now it's fine. So yeah, sorry for this, guys. Actually, I'm facing some issue today. I'm not sure why. Yeah, fine. So I have shared this coding platform. So see this create function. Let's complete this create function as we have discussed here. So yes, we have allocated memory for this new node. So new of data is equal to x. Then new, my bad, new of next equal to null, right? Null. And yeah, finally what we have to do, we have to return the address of this newly created node. So we have to write return new. Okay, so yeah, guys, a lot of question here I'm seeing. Okay, you can use star node dot next. Okay, that's a different thing, guys. Bikram, you have mentioned star node dot next. Okay, I don't want to get into that right now because uh, that's a basically a pointer thing here, and I'm not discussing pointer thing right now. So let's focus on the linked list part. One thing we know is we if we have a structure variable, structure object, we can access the member through that structure object. One way is, let's say structure object is ob, so we will write ob dot data, but here we have pointer to that object. So through pointer, if you want to access the member, we have to use this arrow operator. Okay, as we have done here, new arrow data and all. Okay, fine. So let's yeah, I'm still seeing some discussion about type def. See, guys, type def is just a simple thing. See, okay, if you like, if I write here, I hope you're seeing the screen. If I write here type def int cat, so if in my program, wherever, like if I write cat anywhere now, that will mean this int. So this cat is just a different name for int, like synonym, an alias for this int. That's what I mean. So this, for this entire structure, now this node is a name basically. So for this struct node, now node is another name for it. So wherever I use or wherever I write node, it would mean struct node. That's all. Okay. So see, yeah, you can definitely use in C++, guys. So see here, create. Yeah, so create function is over finally. So let's focus on this insert at end, guys. Okay, so we have, let's say, certain nodes. Okay, we have certain nodes, and now we have to add a new node at the end of the linked list. Okay, so for that I would like to go back to this whiteboard because I need to discuss something there, and then I'll come back to this coding platform to write it down. Okay, so see this. Okay. Yeah. I'll take different scenarios, guys. First scenario, let's say to make you understand the important logic first, let's say I have a linked list containing certain nodes. Okay, there would obviously there would be some data here. So let's say I have this four nodes in the linked list, data 10, 20, 30, and 40, for example. And let's also write the addresses. So this one is 101, this one is 201, this one is, let's say, 301, and address of this node is, let's say, 401. And obviously there would be a head node which would store address of first node. So this one is that. Okay, so we'll have a head node, guys. Head pointer, obviously. So head is a pointer to this top node. It would point to the very first node of the linked list. So here first node is 101. So head is holding 101. So this is a pointer to the first node. Okay. So see here what I'm doing here. Now I want to add a new node at the end of this linked list. Okay, so obviously, first of all, we'll call the create function. So it would create a new node which would be pointed by, let's say, new. Okay, let's take some data for this new node. Let's say I would go with 50, and initially it would be null. So even this would be null. What would be the data here? What would be the value here? It would contain 201 as it is pointing to the next node. Address of next node would be stored here, right? Because this is the data part and this is the next part, pointer to the next node. Similarly, here it would be 301, here it would be 401, and here it would be null as there is no node after it. Okay, fine. So let's take address of this node as 501. So what we have to do here, guys, we just have to link them. Like this should point here. Okay, or you can say I have to store address of this new node 501 here. This is what we need to do here. Okay, so let's do this. How we would do? Okay, so let's talk about this insert function basically. So what I will do is I'll take one more pointer temp. Okay, one more pointer temp, which would initially point to the first node. Address of first node is 101. Okay, and I have to make this temp move towards the end. Like I'd shift this temp here. Okay, then I'll shift the temp here, then I'll shift the temp here. Okay, so I want my temp here. Once I get my temp here, what I'll do is I'll make this next of temp as 501. So like, okay, we'll see how we will shift this temp to the last node. But after we move to that, we just have to write temp of next equal to new. That's all. New is 501 and 501 would be stored in next of temp. That's what we need to do, right? So the next question would be like how to bring this temp to the last node. It's pretty simple, guys. So as I said, let me like erase this part, this one, and I would write it the whole thing. Basically, the logic to bring this temp here to the end or to the last node, you can say. Okay. Okay, fine. Let's do it. So, okay. First of all, we will write node star temp equal to head because I want this temp to start with the first node. Temp should initially hold the address of first node, and address of first node is stored in head. So I'm assigning this value of head to temp. Yeah, Akash, I'm using code blocks. So you can go for that. Code blocks. Okay, you have to install it and you can just write there and execute there. It is an IDE basically. Node start temp equal to head, right? So I want to move this temp towards the end, right? So basically for that I would use a simple while loop. So what should be condition there? Okay, what I would do inside the while loop, I have to shift the temp towards next. So basically I would write temp equal to temp of next. So I'll store temp of next in temp. Okay. So right now temp is pointing to the first node. So the value stored in temp is 101. What I'm doing inside the while loop, I'm storing the value of temp of next. What is temp of next? Right now temp is 101. 101 of next is 201. So 201 would be stored now in temp. So this temp would be updated. This temp would be updated. It would become 201, and now it would refer, excuse me, it will refer here now. Okay, not there. Are you getting my point? So I'm continuously updating this temp value. I'm storing temp of next in temp. So temp is getting shifted, but up to what extent, that decides, that would be decided based on the condition, guys, right? So what would be condition here? Where I should stop this loop? I would stop this loop when there would be null in temp of next. Okay, so till temp of next is not null. Okay, if you are getting confused with this notation, it's very basically same as writing temp of next, okay, my bad, temp of next not equal to null. Okay, you can go with this. So you can just write temp of next, that's the same thing basically, guys. So if you want to write this, you can also go with this. So temp of next not equal to null is our condition. So first time temp is 101, right? Which is and 101 of next, what is there in 101 of next? It is 201, so it is not null. Okay, fine, shift temp. Then what is the current value of temp of next? Temp of next is now 301. Okay, it is not null, so temp would be shifted. So now temp is here basically. So what is there in next of temp? 401, which is not null again. So temp would be shifted. Now temp is pointing here. What is now there in temp of next? Null. So here the condition, loop condition, would be false, and we would come out of this loop obviously. So when this loop has ended, or when the loop has been completed, you will see, or you will get that, or you will realize temp is actually pointing to the last node of the linked list. Now our task is very easy, we just have to link the new node. So basically we have to do temp of next equal to that new node. So we are storing address of new node in next of this temp node, which is the last node. This is what we have to do, guys, when we are going for insert at end. Okay, this case or this scenario was is required or is done when we have certain nodes in the linked list. Okay, let's say we have only one node, for example. Would this code work? Let's say I'm saying we have a linked list, but there is only one node. So 101, this is our head is storing 101, and the data may be 10, and this is null. So will this code work, piece of code work? That is my question. Temp would initially point to the first node. Okay, temp is 101. So the condition, if you see the condition of while loop, temp of next not equal to null, but here temp of next is null. So this loop would stop here. The condition has reached, guys. So obviously you will come out of the loop. So temp is pointing to the last node. Obviously, if you have only one node in the linked list, it is the first node, it is the last node. So anyway, temp is pointing to the last node. You can easily write temp of next equal to new. So basically, it would point to the new node. So this is how you would add a node when you have a linked list having only one node. Fine. So this code is working fine with if you have fine with a linked list having one node or more than one node. Fine. But there is also one more thing, guys. What if the linked list is empty? Okay. So guys, put your comments in the comment box. You write it down some logic. How can we do if the linked list would be empty? Then will this piece of code work? Will this piece of code work if linked list is empty? There is no node at all right now. Will this piece of code work? Whatever I've written here, will this work when we have an empty linked list or there is no node at all?
Okay. No, right? Yeah, great. Not possible. No. Yeah, great, great going, guys. Yes, this is the answer I needed. It would not work because when you don't have any node in the linked list, head would be null, right? So when you are assigning head to temp, so temp would also become null. And what is the loop condition? Condition is temp of next. So you are basically accessing, trying to access next of null, which is not permissible. Error. Okay. So we have to, first of all, before going on this logic, before writing this code, first, before it, we have to check whether the linked list is empty or not. If linked list would be empty, then that means the node which we are trying to add is the very first node. Okay, I'll not waste your time here for that thing. Then let us go to the coding platform directly, guys, and do this bit right there. Okay, I hope you can follow that. So let's not waste our time here. Just a moment, I'll just give you this. Okay, yeah, fine. So see this, guys. So where we were basically, yeah, we have to define this insert. Okay, so let me copy this. Fine. Okay. So yeah, I would go with this temp equal to, okay, okay. First of all, let's before this thing, we have to insert a node, right? So we have the address of the first node, which is stored in head, and we have this data. What is this data? This data is basically, this data is data of the new node, the node which we have to create. Obviously, if you want to add a new node, you have to create that node with this data. Okay, so what is the very first thing we have to do? The very first thing which we have to do is you have to create the new node. So node star new equal to, call this create function by passing this value of x. So create function will take this data x, it would create a node with that data, and it will return the address of the new node, which would be stored in this pointer new. Okay, so you have created the new node. Anyway, you have to insert a node. So you have to anyway create that node. Even if the linked list is empty, you have to add the very first node. If the linked list contains already some node, you have to add it at the end of the linked list, right? Okay, so see this. So I've already created the new node with this data x. Okay, now let's do this. So initially I'll take this temp. I already have the address of head. So head node. So node start temp equal to head. I'm storing address of first node in temp. Okay, that's pretty good to understand. So as I said, we would first check whether the linked list is empty, because that's what we need to check first, right? Before going on to that logic, moving this temp to the last node, we have to check for it, right? So how do we check? We just have to write if. Okay, there are two ways basically. You can actually write if head is equal to null. This is one way. Or you what you can do is you can just write if not of head. So how is this going to work, guys? Not of head. See, if head would be null, if head would be null, then not of null would be true. So if condition is true, that means head is null. Okay, if head is not null, if it is any other value, then not of that would be false. If of that thing, not of something, would be false. So if this condition is false, that means the head is not null. Okay, so see this, if not head, let's do this. If head is null or if not head, so this is the node, or this is the very first node which we are trying to add. So just write head equal to new. Okay, and we just want to end it here. We don't want to continue anymore because we have added the new node, which was our motive. So we can just return from this function, just return head. Okay, when I return head, when I write this statement, you need to understand one thing, guys. Let's go back to this main function to understand this step. See, Here we have created a head node, a head pointer, which is pointing to the, which is supposed to point the first node basically. Now currently it is null because no node at all. Okay, so this head is local in the scope of main function. Okay, this is local in this main function, and whatever head we are dealing with inside this insert end, this one, this head is basically local within this scope, this insert end. So there are basically two head. One is local of main function, and one is local to this insert end function. What it head? There are two head here. One is of main function. One is of this insert end function. Okay, right? So now I have changed this value of head. I have written here head equal to new. Does it mean we have actually changed the original head that is there in the main function, because we have considered that that is the original head, which is the which would be holding the address of the first node? No, right? When we are changing value of head here, this head basically is local to this insert end function. So we have not changed the original head. Okay, that is why I'm returning this value of this local head, current head, that is supposed to be stored in the head of main. So then I can say, okay, the original head has been changed or modified. That is why I have kept this return type of insert end function as node star, because I am returning address of a node, basically the first node. Okay, right? Got it? Yeah, fine.
Huh?
So this is how we do this. So we are ending this function. We are returning from this function here itself. If our linked list is empty, we are adding the new node at the head, and we are returning the address of head node, guys. Okay. What if we
Suraj
globally
sir,
declare head? Yeah, that is also fine, guys. If you declare it globally, that is also fine. But why I restrain from like this declaring head as global? Because there is a chance that we can mess it up. Okay, somewhere we would be using head unintentionally, and that would actually disturb the entire linked list. I don't want that. Even if I do use somewhere, that would not disturb the original head. Okay, right? Fine.
sir,
So let's see this. So yeah,
Suraj sir.
continue with that. So this condition if is for the situation where linked list is empty. Okay, if this condition is false, let's say head is not null, that means there are certain nodes, right? So we have to now go back to that logic, like we have to shift them till the last, and we know, right, we have to go for this while loop, and we have to write while temp of okay, temp of next not equal to null, or you can just write temp of next. That's the same thing. I guess I have explained that. So while temp of next, temp equal to temp of, oh my bad, temp of next, right? Got it? So this is like after this loop, it is pretty sure that temp would be pointing to the last node. So after this, what we have to do? So we have to store this new in temp of next. Okay, and yes, finally we would again return the head. Why we have to return anyway something, because return, that is a return type, right? It is node star. So when this condition is true, it would return head. Again, if it is not true after this operation, it would again return head. Okay, guys. Okay, so I hope this thing is clear to you. This insert operations, this is insert at end, guys. I hope this thing is clear to you. Okay, have a good look on this logic of insert end. There are certain scenarios here. through which you
Huh?
would basically understand. Okay.
So what's up?
Yeah, have a good look here. So there are two things
Hello?
basically. Is create, okay, which would just create and return, and then we have this insert end. Okay.
Yes, guys, I'm putting the attendance link in the
So
chat.
guys, yeah, I understand it's time for your attendance. Just give us a minute. It would be shared with you. Just a moment, guys. Yeah, it has been shared.
Yes, so we can continue.
Yeah, guys. So I hope everyone has done with the is done with the attendance thing. So let's continue our discussion. So we have done this insert at end, guys. What we need to do now is let's do a quick discussion on insert at beginning. That's very simple, guys. So let's do it right now. Just clear the canvas for you, and yeah, let's see. Okay, let's assume that first of all, let's assume this scenario that there is there is a linked list having some nodes. Okay, okay, this doesn't look good. Yeah, this is kind of fine. Okay, yeah, so yeah, pretty good. So there are four nodes there and some data. Let's put it here, like 22 and 15 and let's say 19 and let's say this is 35. Okay, these are the data, let's say. And yes, we will have definitely have a head pointer which would be pointing to the very first node. So let's give some dummy addresses, guys. Here, so this is 101, 201, let's say 301 and 401. And yes, our head would store this 101, right? So we have this link list. I have this linked list having this four node having this values. So we have to now insert a new node at the beginning. So obviously we have to create the new node. Fine. This is our new node. Let's say address is let's say 501. So this is a pointer new which will store 501, and we say this new is pointing to this node. And data, let's take it as maybe 7. Yeah, let's go for 7. So what we need to do here, basically, there are two things we need to do, guys. Initially, this thing would be null. So what changes we have to do? First, we like basically we have to point this one, like we have to store address of this node here, so that next of this new node will point to the this node, basically. Okay, this node. And one more thing, then after that we have to shift this head to this, because we have inserted a node at beginning of the linked list, so new node should be the new head node. Okay, these two things we need to do here. Okay, so let's basically, I guess it's very easy. I guess you can easily do this. So first of all, what we will do, we would create a new node by calling this create function. Create data, maybe data is 7, right? Yeah, so we have created new node with data 7. Fine, so we have this node. Let me erase this this one, all this thing. Okay, and as I write down the statement, I would like draw these pointers, then it would be pretty like better. Yeah, okay, fine. Yeah, it's fine, it's fine. So let's get back to this instructions. Okay, so I've created already a new node, new is pointing to it, and what we need to do here is I have to write new of next equal to head. Okay, new of next equal to head. Then we have to change this head, so head equal to new, because new node should be the new head, obviously, because that is now added as in the beginning of the linked list. Okay, then yeah, what we have to do, we have to return the new value of head. As I already said, when you are changing head in this function, your original head that is there in the main function is not getting changed, so you have to return the new value of head, which would be assigned in the original head over there in main function. Okay, the same concept here. Okay, uh, so see this. Okay, this is the scenario where we are discussing, like where this linked list have some node. Let's talk about if there is only one node. If there is only one node with some data, let's say 10, and this is null. So this would be the head node. Will this piece of code work? Will this piece of code work? Answer would be yes. Okay, so we have a single node. So basically, we would create a new node, right, which would point here, and then we would change head here. That's all. So this piece of code will work, like definitely work, when we have only one node in the linked list. What if we have an empty linked list? We have an empty linked list. If the linked list is empty, what happens here? So when linked list is empty, then head would be null. So basically what we will do, this would create a new node. Fine, let's say address is 101, data would be 7, this would be null. Fine. New of next equal to head, which is new. This node, new node is new, right? So new of next equal to head. What is there in head now? In head, null is stored. So null would be again stored here. Fine. This is the very first node, right? Then what we are doing? We are storing new in head. So it would store now 101, right? 101. So now head would point to this node. Yeah, task is done. So this code even works for a linked list which is empty, which doesn't have any node. Okay. Yes, guys. So a few of you are asking about the time complexity of this code. If you are talking about insert at beginning, this would take a constant time. You can see there is no loops involved here. So just a certain number of constant time step. Okay, create, it would just allocate a memory and return constant time. Okay, this is also a constant step, this is also a constant time step, and this is also a constant time step. So this is basically constant, big O of 1. Insert at beginning would take big O of 1. Okay, if you talk about insert at end, so there, okay, if the linked list would be empty, then it would take only like constant time. You are just creating new node and head would be pointing it. That's all. But what if linked list is not empty? So we'll always go for worst case, right? So in worst case, we have to shift temp from head node to the last node, and that's where we are using a loop, while loop, so which would move across n number of node. If the linked list contains n node, then we have to traverse it n nodes, so that would take big O of n, guys. Insert at end. In worst case, obviously we are basically concerned about worst case, so that would take big O of n. So yeah, pretty much clear, guys. This is what I had planned for this session. So I think this went well with you, and you could understand whatever I have discussed. Time for assignment question. So as we discussed, guys, like insert at end and insert at beginning, I would like you all to write the logic for insert at any given position. Okay, you have to insert at any given position. Let's say I want to insert a new node at fourth position. So what is the fourth position? This is the first position, this is the second, this is the third. So I want to insert a new node here. Okay, or let's say let's go with this simple thing. Let's not make it more tough by doing this. Let's go by this. Let's say this is position 0, this is position 1, position 2, and this is position 3, and I want to insert a new node at position 2. That means I would insert a new node here. How to do that? So position would be taken input by the user. Based on that, you have to write a code. Okay, basically you have to change the logic for this while loop. Okay, and yes, of course, you have to keep in mind whether the linked list is empty and all. So you have to keep those in mind and try to figure out this. And yes, along with that, I would like you all to also go for the delete operation. Okay, delete operation. Think about it, do a bit about it. Like, okay, I'll just give the easy one, delete at beginning. You just do the delete at beginning. Okay, delete at delete from end is basically, it would be similar to insert at end. We have to this take this temp up to there, and we have to remove that thing. For that, I would give you one information, guys. See, just a quick information about this dynamic memory allocation. Whenever we are allocating memory statically, when a memory is allocated statically, so when you are out of the program, not sorry, when you are out of the scope, let's say this is a function void f, and inside the function I have created a variable, let's say x. Okay, and I have assigned some value there. So as long as you are inside this block, your x is there in the memory. As soon as you get out of this block, this x would be automatically deleted. It is a local variable and also say auto variable, so this would be deleted automatically. But this thing doesn't happen when you allocate memory dynamically. When you allocate memory dynamically, you have to deallocate it. Okay, of course, when you are out of the program or the program execution is over, obviously all the memory allocated by that program would be deallocated anyway. But like when you come out of the scope of this block, as here it happens, dynamically allocated memory doesn't behave in the same way. So you have to free that up by using this. You have to deallocate that by using this free function. How to deallocate? Pretty much easier. If p is a pointer which is pointing to that memory which has been allocated dynamically, so you just write free p. See, guys, there are certain like many concept behind this thing. Memory leak, what is dangling pointer, kind of those pretty small things are there, which is very important also. Okay, so what I'll do is I would discuss this dangling pointer and memory leak thing in the next session. I'll keep that for the next session, and then I'll move forward with the other things kept for the next session. Okay, so Yeah, guys, so I hope I could meet up your expectation for this linked list thing. Yeah, I know we could not complete all the operation. There are a lot of operation and it really takes a lot of time to cover all the operation, but whatever we have done, I think it's pretty good. So you just try to do this, insert at any position, and yes, delete a node from beginning and end. Okay, so great going, guys. So take care. So we'll meet in the next session. Bye and take care.
Thanks a lot, sir. Guys, make sure you have marked your attendance. We'll be meeting tomorrow. I hope this was a good session. Also, make sure you register on the website. We'll be having sessions on our LMS from tomorrow. So make sure you have marked your registered on the website and be there. We'll